This research is focused on answering questions around how we can use deep learning to model highlight moments, i.e., those most interesting to the viewer in live streams. Live streaming and esports in general is becoming a larger and larger part of the gaming ecosystem, and as such, it's becoming more and more pertinent to explore how we can utilize these new forms of media to better understand the video game paradigm. Models developed for this research have three core components. Firstly, the feature extraction network takes raw data directly from a game stream and extracts important features so they can be used in later parts of the model. Largely, this is done with a neural network, especially in the case of image data, but alternatives such as audio frequency analysis have also been explored. Next, fusion is carried out, whereby the data from each of these data streams is combined together. Because live streaming is an inherently multimodal domain, it is really important that we join these data streams together to form a single input. In a simple case, this is carried out by concatenating the features, but more complicated techniques, such as utilizing tensor decompositions, have also been experimented with. The final step, once features from all the data streams have been extracted and fused, is to decide if the incoming data consists of a highlight or not. As with feature extraction, this is generally carried out using a neural network, although outlier detection techniques, such as one-class sport vector machines, are currently being trialled with promising preliminary results. This research is largely focused on how we can build such models in an unsupervised manner. Unsupervised or self-supervised learning has the advantage that it can leverage massive datasets. This is because unsupervised learning removes the requirement to hand label videos, which massively reduces the human load on data gathering. The challenge, however, in using unsupervised learning is that we lose direct connection to which inputs are strictly highlights and which are not. This problem can be further exacerbated by the inherently subjective nature of highlights. So far, we've been using two techniques. Firstly, measuring the novelty of the input compared to the rest of the stream can be considered an intrinsic method for highlight detection. Highlights by their nature must be novel, as there must be some part of the highlight which makes it interesting to the viewer. Such techniques show promise in games like PlayerUnknown's Battlegrounds, where the moments of action are visually and audibly very distinct from the rest of the footage. However, such methods do not translate well to strategy games where the context of a moment is extremely important. Secondly, crowdsourcing is currently being experimented with. For certain esports, such as League of Legends, there exists a wealth of both original broadcasts and human-made highlight videos. Whilst we still lack the direct connection between the highlight videos and the original broadcast, making supervised learning impossible, we can leverage this data to generate highlight videos. The League of Legends footage that you have watched was edited using a model utilizing crowdsourced highlights, whereas the PlayerUnknown Battlegrounds footage utilizes novelty-based highlight detection. Throughout this talk, I have neglected to discuss text data from chat logs. This is the most challenging of the data streams. Our studies of this data demonstrate that it is very different from any other forms of text data, even social media data. Therefore, it is difficult to utilize this data stream without having a large amount of work to understand it first. However, plans for future work include exploring text chat with a view to incorporating it into the techniques described above in some form. If you'd like to read any of the publications related to this research, or would like to get in touch, you can find me online at charlieringer.com or Twitter at charlieringer.